As we have already seen, starting from a simple image analyzer, we reused the same pipeline for multiple real-world applications such as Aadhaar card verification, fault detection, code generation, and nutrition analysis. Now we take this idea one step further. Instead of analyzing one image, we allow the system to analyze two images together and answer a user-defined question based on both images. Here the application works as follows. The user uploads two images. After the user asks one question that you can see, which crop appears healthier and why? This question asked by the user. Let's press enter. The model visually inspects both images together. The model answers the question using visual reasoning. So you can see comparison result. As I just said, the model answers the question using visual reasoning that you can see here. So here we will go through a few case studies to see how the same image-based pipeline can be reused for different real-world applications. We are going to discuss case studies like food comparison, resume layout comparison, and crop health comparison. So let's get started. As you can see here, we are importing required libraries. These imports are exactly the same as all previous applications. We are still using LangChain, a multi-model model, base 64 encoding, and Streamlit for the interface. There is no change here. Now here we are loading environment variables. This line is unchanged. The OpenAI API key is loaded securely from the .env file that we have created earlier. Here our encoding function. This function is reused without any modification. Now here we will encode two images instead of one, but the function remains the same. Here now we are initializing same multimodal model. Again, no change here. We are still using the same multimodal model that understands text and multiple images. This capability allows us to compare images visually. Now I have changed the app title that you can see. Compare two images, ask a question. So this title clearly tells the user that two images will be uploaded and a question will be asked from them. This sets the context of the application. Now here image upload inputs. So here we introduce the second image input. Earlier every application accepted only one image. Now we explicitly allow two images. The upload mechanism is the same, only the count changes. In place of one, currently we are taking two images from the user. Here taking question from the user. So this is the most important addition in this case study. Here user will decide what to do by asking a question. This makes the application question driven. Now our validation. If image 1 and image 2 and question this. So the application runs only when both images are uploaded and a question is provided. This avoids incomplete request. Now here we are calling our encode_image function, this one. You can see that we are calling the encode_image function twice here. The logic remains the same. Both images are converted into base 64 format so they can be sent to the model. Now the core logic, our chat prompt template class. This is our system message or system prompt. Here human or user prompt. You can see the system prompt. You are a visual reasoning assistant that compares two images. So the system message defines the role of the AI. Earlier the model acted as Aadhaar verifier, fault inspector, front-end developer, and nutrition assistant. Now the model acts as a general visual reasoning assistant that you can see that we are providing inside the system prompt or system message. Now human or user message, you can see user question. Here we are passing question that we are receiving from the user to our web application, right? And here I have given some instructions. You can add more as per your requirement. Like what if the image is blurred, that we can't see, right? That you can add as per your requirement. But here I have added these many instructions that you can see. Identify what is shown in the image 1. Identify what is shown in image 2. Check if both images belong to comparable categories. If comparable, compare them based on the question. If not comparable, clearly state that comparison is not possible. Provide the answer in clear bullet points and with a one-line conclusion that you can see. As I said, you can add more as per your requirement. You can see both images are attached in the same way as before in base64 format. The only difference is that now the model receives two images together in place of one that we have used in previous applications. But currently we are using two images, right? Now our LangChain pipeline, this line is unchanged. We are providing prompt to our multimodal model GPT-4o, right? This one. Here we are invoking chain with user question and with both images. And here we are printing result on our web application. So the model's answer to the user's question is displayed on the screen, means on our web app. Let's execute our application. Now let's open new terminal. Let's clear this and we have to run like this because this is Streamlit web app. Streamlit run 2_images.py. This is our file name. Let's press enter and you can see this is our web application. You can see the title that we have given, compare two images, ask a question, and here user can upload image 1, user can upload image 2, and user can ask a comparison question. So now let's take our first case study, food comparison. Here we will upload two food images and see how the system compares them. So let's take our first image and upload it. Let's take our second image and let's press this open. Now here let's ask a question. Which food is healthier? Let's press enter, and for your information I have used these two images. This is the first image that I have uploaded and given to our web app, and this is our second image that we have used, right? And you can see the great comparison result. It is showing about image 1, image 2, comparability that you can see. Both are food items, comparable in context of healthiness that you can see here. Great, right? And also comparison. And final conclusion. You can see the conclusion. The salad is healthier than the burger and fries. You can see the result clearly, right? Because our prompt is designed properly that you can see, right? Because of this instruction, we are getting this clear result. So that's why the system behaves exactly as expected that you can see. So as I said, based on your requirements, you can always customize the prompt to get the kind of output you want that you can see, right? Now let's reload this web app and let's check what will happen if two images uploaded by the user are not comparable. So I am taking one food image and another crop image, right? And again, I am asking the same question. Which food is healthier? Let's press enter and great. You can see image 1 and image 2 and about comparison. The items are not directly comparable as one is a prepared meal and the other is an agriculture product. And you can see the final conclusion. These images cannot be compared for healthiness. You can see the result clearly because our prompt is designed properly that you can see. Now let's move to our second case study, resume comparison. So I will upload two resume images and ask a comparison question. The question may be which resume looks more ATS friendly or which resume has better section organization. Any question you can ask. So let's first upload two resume. This is 1 and this is 2. Now let's ask one question. Which resume has better section organization? Let's press enter. So for your information, I have uploaded this resume. This is first one and this is second resume, right? And great. You can see comparability. Both images are resume and are comparable based on section organization. And you can see output is both resumes have well organized sections with a similar structure that you can see, right? Great answer from GPT-4o. Now let's refresh this and let's move to our third case study, crop comparison. So in this example, we will upload two crop images, one with plant disease and another showing a healthy plant, and see how the system analyzes and compares them. So let's upload crop 1 image and let's upload crop 2 image. And for your information, I have uploaded this image. This is the first image that you can see, and this is second crop image that we are using here. Now let's ask question, which crop appears healthier and why? Let's press enter and you can see great result. Image 1 and image 2 description both are comparable. You can see in the image 1 plants appear unhealthy and in image 2 plant appear healthier. You can see crop in image 2 appears healthier due to its vibrant green leaves and absence of visible plant stress that you can see. Great comparison, right? I hope all of you are clear with this, right? How to implement this application. In all these case studies, we did not change the prompt or application logic that you can see. We used the same image comparison pipeline throughout. Only the input images and the user's question were different. Based on these inputs, the model analyzed the images and produced the required output that you can see. You can see this clearly shows that with a well-designed multi-model pipeline, you can solve multiple real-world problems simply by changing what images you provide and what question you ask without modifying a single line of code that you can see. Hope all of you are clear with this, right? Let's move on.